Alright, second time making this video. The first time I forgot to put on the sound. Alright, today we merged calculators with logs. So the key thing is our calculator works in two different bases. It works in base 10 and base E. So now your initial question, what is E? E is a number. E is roughly 2.718, and know what it reminds me of? It's kind of like pi. It is a symbol, in this case a letter, that represents a number. Now our calculator has two buttons that work with logs. When we are working in base 10, we are what's called working with a common log. On our calculator, the log button is for a log base 10. The other option is working with base E, which is called a natural log. So the LN button, not drastically different, it's log base E. So really you could have, imagine a calculator had log base 4 button, log base 5 button, log base 6 button. That's the exact same idea here. So I'm not really going to focus on E today. E's going to come in a little bit, but I just wanted to present it with this calculator idea. What we have today is called the change of base property. And when we do this, both logs are in base 10. So if you have log base B of M, you could rewrite this as log base 10 of M over log base 10 of B. So for this problem here, the question is 2 to what power is 24? Well, I don't know, but know what? I can use logs to help me out. If I do log 24 divided by log 2, my calculator tells me that 4.585. So the question is, 2 raised to the 4.585, is that 24? Yes, it is. Alright, so keeping it really basic, the question here is 3 to what power 7? Well, log 7 divided by log 3, what does that equal? 1.771. Plug in, check. Take the time to know for sure that this actually works. Skipping to problem 3, we have it in exponent form. If you cannot solve something in exponent form, we have to make it into log form. So this can become log base 3 of 4 equals x, which using our change of base property, log 4 divided by log 3 gives us, in this case, 1.262. Oops. 1.262. And what do? Plug in, check, know for sure that your answer is correct. It's the best part of this unit. You can check everything. Alright, last one. We gotta isolate that 5 to the x power. So what do? Subtract 2. Multiply by 2. And now this gives us to a problem similar to problem 3. Power 5 to the x equals 16. Well, log base 5 of 16 equals x. Log 16 divided by log 5 equals x, which in this problem is 1.723. And what do? Plug in, check. Take the time to know that your answer is correct. And now with the problem we just looked at, before converting to logs, what we did before was we isolated. We isolated that exponent piece. By doing that, we were able to work things out. Alright, so we divide by 2. 9 to the x equals 3.5. Convert to logs. Log base 9 of 3.5 equals x. Log 3.5 over log 9 equals x. What is your final answer here? 0.57. And what you do? Plug in, check. Know for sure that your answer is correct. So just check in for a quick moment. Yep, works. Is it exactly 7 when I plug in? No. Why? Because I rounded. Due to rounding, it's not going to be perfect. Alright, time to isolate. 6 raised 7 to the 3x equals 18. Divide by 6. 7 to the 3x equals 3. Convert to logs. Log base 7 of 3 equals 3x. Change of base. Log 3 over log 7 equals 3s. Get x by itself. Divide everything by 3. What does this actually equal? Log 3 divided by log 7, then divided by 3. 0.188 is our final answer. Plug in, check. I'm going to say that every single problem. Plug in, check. Plug in, check. Plug in, check. Making sure we got it. Alright, before we get to some practice problems, I hope people have picked up on this, but in case you didn't, I just want to make sure we got this idea. So for this problem here, the answer to this is 3. And the general rule is going to be that if you have log base b of b to the x, it equals x. And the reason is this. If I convert this into exponent form, 6 to the x equals 6 to the third, x equals 3. Now, I don't want you to do that in the future. I want you to pick up on this rule. So, it's like what we have is log base 2 of 2 squared equals 2. What this is really log base 2 of 4, which equals 2. Because the question is, 2 to what power is 4? And now everything, log base 3 of 9 equals 2. Log base 4 of 16 equals 2. Log base 5 of 25 equals 2. Log base 6 of 36 equals 2. Log base 7 of 49 equals 2. Because in all these situations, 7 to what power, 6 to what power, 5 to what power, 4 to what power, 3 to what power, right? All of them being squared gives us that argument number there. Alright, this one is 11. Now what makes this weird for a lot of people is the exponent is that, log base 4 of 11. This is an exponent form. If we convert to log form, log base 4 of x equals log base 4 of 11, x equals 11. So we have b raised to log base b of x equals x. And this will hold true every time. And again, is it always going to be so obvious? So imagine we had 4 raised to log base 2 of 5. Well, you know what? I know we got 2 squared. And I could use my power to a power rule to get this. Now, what happens now is that number in front's an exponent. Log base 2 of 5 squared, which gives me log base 2 of 25, which gives us the entire thing equals 25. So not every time is it so obvious. Sometimes it takes a little bit of work, but it's there. Look for these rules, look for these tricks. They help you out, they make your life easier in these situations. Alright, I'm skipping 1, I'm skipping 2. They're pretty straightforward. I'm going to 3 and 4. Divide by 4. 23 to the 0.2x equals 92.75. Convert to log. Log base 23 of 92.75 equals 0.2x. Log 92.75 divided by log 23 equals 0.2x. Divided by 0.2. X equals 7.224. Check. Plug in. Check. Know for sure that your answer is correct. Minus 4. Divide by 3. Convert to logs. Change the base. Divide by 2. What does x equal? 0.534. And what do you do? For the last time I'm saying it, check. Take the time, check. make sure you know your answer is correct.